sulfur.
What is sulfur? Well, I'm Ansh Guglani, and I'm going to teach you everything I know about sulfur, starting right now.
To begin, sulfur is number 16 on the periodic table of elements, meaning it has 16 protons and has an atomic mass of about 32 AMU, and is solid in its normal state. It can be many shades of yellow and is often found in powdery rock form. Sulfur is in family 16 of the periodic table, called the chalcogens. Some chemists call this element family the stinkogens, because many of them create smelly compounds. In its most common isotope, sulfur has 16 neutrons. However, it can also have 17 or 18 neutrons. Now for some history. Cultures around the world have known about sulfur for thousands of years, but it wasn't until 1777 that Antoine Lavoisier, a French chemist, convinced the scientific community to look at sulfur as an element, not a compound. Sulfur has over 30 allotropes. An allotrope is a structural form of a pure element. One allotrope is S8, which looks like this, which is a ring of 8 sulfur atoms. Sulfur can look like this and this, but most sulfur looks like this, which is S8. Have a closer look. Its crystals are in an ortho-ombric shape, which sort of looks like this. Now that you know some information about sulfur, let's go to the lab and see something interesting. Welcome to the lab. Now I'm going to be showing you what happens when sulfur is burned. Did you know that matches are made of sulfur? When you burn sulfur, you're actually causing it to merge with oxygen in this chemical equation to produce sulfur dioxide, which is the smell we know as rotten eggs. This is sulfur dioxide, a combination of sulfur and oxygen held together by covalent bonds. It is toxic in large amounts, is noxious, and can cause acid rain. Sulfur is a nonmetal. Therefore, it combines with other nonmetals, such as oxygen. Now, let's talk about sulfur in compounds. Welcome back to the lab. One of the more exciting sulfur compounds is called sulfuric acid, or hydrogen sulfate. This is sulfuric acid. The yellow is sulfur, the reds are oxygen, and the white is hydrogen. As you can see, it is basically a sulfate ion with 2 hydrogens attached. Sulfuric acid is one of the strongest acids we know of, so I must have protection. Let's glove it up. First we add 30 grams of sugar and mix it to 15 ml of 18 molar sulfuric acid. As you can see, when we mix it, it turns from an amber color to a dark black color. As the reaction progresses, we see some reaction. You can see here how the sugar is dehydrated by sulfuric acid into pure carbon and water. This means that the black mass we saw forming was pure carbon. This demo really shows the power of sulfuric acid. Now, let's go halfway around the world to see other applications of sulfur. Ancient China, home of the Great Wall. In the 9th century AD, Chinese alchemists were searching for a magical elixir of immortality and mixed saltpeter or potassium nitrate, charcoal or carbon, and sulfur together in a granular solid. However, when they lit it on fire, they found a violent reaction took place, and the substance burst into flames. The Chinese discovered gunpowder. Sulfur is a vital component in gunpowder because it lowers the energy of activation so that the mixture burns in a flash rather than a slow burn. You can see here how sulfur is involved in the combustion of black powder. After its discovery in China, gunpowder spread across the globe and changed the world with its recreational and military applications. So in essence, sulfur changed the world. Well, there you have it. I've taught you everything I know about sulfur, from its atom to ancient China. We hope you've enjoyed this video. Thanks for watching.